Hi. Okay, so about pedestrian modeling in AnyLogic, we'll be creating the airport model step by step as per the instructions in the AnyLogic in 3 days. So I'll try to go through it as much as possible. Okay, so we are going to build a model that simulates how passengers move within a small airport that's going to host two airlines, each with their own gate. So passengers are going to arrive at the airport, check in, pass the security checkpoint, and then go to the waiting area. After boarding starts, each airline's representatives check their passenger's ticket before they allow them to board. So there are 6 phases. Uh, in this one, we are working with the first phase. So, excuse me. So in the first phase, we'll be learning how to read the database's flight data, which is going to be in a Microsoft Excel spreadsheet, and we are going to configure pedestrians by assigning flight information to them. So phase one, defining the simple pedestrian flow. So in the first phase, we are going to use an AnyLogic pedestrian library to create a very simple model of an airport where passengers arrive and then move to the gate. So about the pedestrian library, okay. So traditional modeling methods such as the discrete event and queuing may not work well in areas with high amount of pedestrian movement. Okay, so any logic pedestrian library simulates pedestrian flows in physical environment by allowing us to create models of building and areas with large number of pedestrians such as subway station, security checkpoint, and street. So our model's pedestrian move is in continuous space while they react to obstacle and one another. This allows you to collect data about a given area's pedestrian density, ensure acceptable performance level for service point with a hypothetical load, estimate how long pedestrians will stay in specific area, and detect potential problems that interior changes such as adding or removing obstacles may cause. In most cases, we will start to create a pedestrian dynamics model by adding the simulated building's layout and then drawing walls over it. So the first thing we are going to create a new model and name it airport. Select minutes as the model time unit. Then we are going to drag an image from the presentation palette onto the main diagram. We are going to choose the image, which is going to be in the AnyLogic folder, resources, AnyLogic. So let's go to AnyLogic, create a new model. Let's name it airport. The model time is going to be minutes, and we are going to click on finish. Next thing, we are going to go to the presentation under the palette, and from presentation we are going to drag the image, and let's say we keep it here, and we are going to go to our C drive where the AnyLogic is installed, and in the resources in 3 days airport terminal. So this is our terminal. Okay, so let's say if I just make it a little bigger. Okay, now let's go back here. Once you have done that, the step 4 is on the main diagram, place the image in the blue frame's lower left corner. If the image is distorted, click the reset to original size button, then select the lock checkbox to lock the image shape. So if the image gets distorted, we can just right click and we can find in the properties reset to original size. If not, we can just resize it and we can lock the image. Okay, so once locking it, the size is not going to change. Now Uh, we cannot. Yeah. So the image is locked. We cannot click it anymore. So now we will use a set of space markup shape from AnyLogic Pedestrian library palette to define our pedestrians model space. We can use the space markup shape to draw walls, services, locations such as turnstiles and ticket offices where pedestrians receive services and waiting areas. So in the pedestrian model, these things are available. So you're going to use the wall and objects within our model simulatory space that pedestrians cannot cross. So the pedestrians cannot cross the wall. Okay, so it's going to treat the wall as an obstacle. To start creating our model, in simple term, we are about to use the three markup shape below to place analogic walls on top of the walls that appear in our image. So there is the wall, which is going to be used to draw the exterior and interior wall. The rectangular wall, the shape is going to draw rectangular areas such as working spaces that aren't accessible by pedestrians. So it's like a restricted zone. And circular wall, the shape to draw a circular obstacle such as column, pools, and fountains. So we are going to use the pedestrian library palette to draw the airport's wall. Double-click the wall element we will find in the pedestrian library's palette space markup section and draw the wall around the airport building's border by clicking your mouse each time you want to add a point. When you are ready to set the wall's final point, double-click your mouse. So we are going to draw the outer walls. Okay, so let's go back to AnyLogic and excuse me, and let's go to pedestrian library here. Okay, and we are going to double click on the wall. I'm going to zoom in. So I'm going to start from here. Next point is going to be here, here, here. mm, The walls are getting a little distorted. Here, then here. Okay, so I'm just going to fix the walls here. I can just click on these points and make sure it's perfectly aligned. Hmm. Now I'm going to zoom out. So this is how it's going to look. Okay, once we have done that, we can change the wall's appearance by choosing a new color and height. Navigate to the wall's properties and then select the color Dodger blue in the appearance section. Now that we have defined the building's walls and chosen their color, we'll use the special target line space markup element to ensure model's pedestrians appear at the airport entrance and then move towards the gate. So you can just go to the appearance and change the color to Dodger blue. Now we're going to work with the target line. So in the pedestrian dynamics model, The target line element defines the locations where pedestrians appear in the simulated space, where they wait. Through areas typically define waiting location and their destination. So target line does three things. Okay, either pedestrians can appear where they can wait or their destination. So one target line has three functionality. So we are going to define the location where our model's passengers appear by dragging the target line element from the pedestrian library palette onto the graphical diagram as shown is in the figure below. So here we're going to place the target line around here. So in the pedestrian library target line, we can just double click and we can just have the line here. So this target line is going to represent where the passengers are going to appear. We don't need to do anything, we can just keep it there. So we are going to name this as arrival line. We can change the color here. So we are going to define a second target line that passengers will move toward after they enter the airport. Place it in the gate area as shown in the figure below and then name it gate line 1. So here is going to be the gate line 1. So we're going to take another target line and we are going to put it here. Get line 1. Okay, and in the next one, so here is a note. Our model's target line elements and space markup shapes must lie inside the wall. If any of your model space markup shapes touch a wall, the exception during the discrete event simulation unreachable target error may display at the model runtime, which means that this target line has to be inside the wall. If you put it on top of the wall, you might get an error when you run the simulation. So we have marked the space that defines our simple pedestrian model and we will not use a flowchart to define the model's process logic. And we will now use a process flowchart to define the model's process logic. Okay. So before we move to the logic, I am going to break down this video here. So I'll be seeing you guys in the next video. So until that time, have a very good day. Thank you.